Alright, so for number 9, they're asking those four things: the intercepts, the intervals where the graph is increasing, decreasing, and the relative max min. So that's what the relative extrema means, to give the maximum and minimum points. So let's start off with the x-intercept, or intercepts. So we see there are 1, 2, 3, 4, 5. So I'm just going to list them. Negative, oops, change the color. Negative 2 pi 0, negative pi 0, 0, 0, pi 0, and 2 pi 0. Any function can have at most one y-intercept, otherwise it's not a function, so the y-intercept is 0, 0. Where is the graph increasing? In what interval? So from here to here, from here to here, and from here to here. So those intervals would be negative 2 pi to negative 3 pi over 2. And it looks like an ordered pair, but it's not. It's an interval. It's telling you where it starts and where it stops on the x-axis. Like along, for not along the x-axis, but for the x values where it starts here and it ends right here. The next one would be negative pi over 2 to positive pi over 2. And then the third one would be from 3 pi over 2 to 2 pi. That's where it's increasing. Decreasing would be from here to here and here to here. So it only has 2 intervals. So negative 3 pi over 2 to negative pi over 2. And then from pi over 2 to 3 pi over 2. Okay? Relative maximum points, it has one right here and one right here. So those 2 points, one of them, the first one would be negative 3 pi over 2, 1. The other one is at pi over 2, 1. So for relative minimum, that would be this point right here and this point right here. So that would be at negative pi over 2, negative 1. And at 3 pi over 2, negative 1. Alright, so for 11, they're asking you to state the period and amplitude. So 11 has several periods graphed on here for the equation y equals 3 sine 2x. So I'm going to just outline one of them. So that's one complete cycle right there. Okay, everything else is just a repetition of that, right? So from here to here, that's from, from here to here, that's pi units, because this is 2 pi, radians. That's 2 pi, so that means this is pi. So the length of this period is pi. Okay? And then the amplitude, you could see up here, it goes up to 3. So I could have done that same thing with the equation that's up here, but I wanted you guys to look at the, follow the graph and answer the 2 questions by just looking at the graph. Alright, so here we have 13 through 19, and they're asking for the period and the amplitude, and I've already set them up where I have 2 pi over b for each one to get the period, the length of the period. So for 13, 2 pi divided by a half is the same thing as 2 pi times 2, so that ends up being 4 pi. The amplitude is 5. 2 pi over pi, the pi's cancel, so the period is 2. And the amplitude is 2/3. 2 pi over 1 is just 2 pi. The amplitude is 2. So even though there's a negative, the negative just indicates the reflection over the x-axis, but the amplitude itself is 2. 2 pi divided by 4/3 is the same thing as 2 pi times 3/4. So if you put 2 pi times 3/4, the 4 reduces with the 2, and you end up with 3 pi over 2 as the period. And the amplitude is 1/4. Alright, so they want you to describe the relationship between f of x and g of x, and to talk about that in terms of like their amplitude, period, and any shifts, any shifts. Okay, so for 21, amplitudes, they have the same amplitude, which is 1. Period, they have the same period, which is 2 pi, because the b value is 1, so both of them have, the x's have a coefficient 1. Shifts, f of g of x is shifted to the right, so compared to f of x, g of x shifts to the right pi units. Okay? Number 23. Their amplitude is the same. Oops, why did I write amplitude? So the amplitude's the same. The only thing is that g of x reflects over x-axis. That's what that negative does. Okay? That's g of x. And their period is the same, which is 2 pi over 2, which is pi. And there are no shifts in either one of them. Okay, 25, the amplitude is the same, which is 1. The period is the same, so it's 2 pi over 2, just like number 23, which is pi. For this one, g of x shifts 3 units up. Okay? Number 27, the amplitude is not the same. So for f of x, the amplitude is 1, and for g of x, the amplitude is 5. So g of x is 5 times taller. Period is the same, so the same, 2 pi over 1, which is 2 pi. As far, well, what does happen though here, it's not shifting, but it is reflecting. So g of x reflects over the y-axis. So I could put it either under, I'll put it under period. G of x reflects over y-axis, not x, but over y-axis. And there is no shifting. And that's it for these. Alright, so 29 and 31, we're analyzing the graphs and comparing f and g. So if you look at the picture right here, the graphs, g is higher, it goes up to 2, whereas f of x goes up to 1. So their amplitudes are not the same. So for f of x, the amplitude is 1, and for g of x, the amplitude is 2. The period is the same, because notice how they cross the 0 in the same spot all the way across. So the period is the same. And I mean, there is no shifting that we can see, right? Because it's the maximum is the maximum in both, minimum is minimum for both, zeros is the same for both. So that's it for number 29. Number 31, the amplitudes are the same, right? They have the same maximum and minimum values. The periods are different. No, so actually take it back. Periods are the same, okay? Because they have, if you look at this one, 1, 2, 3, it goes up to 4 pi, right? So this period is 2 pi. And then if I take this piece of the curve from here to here, that's also 2 pi right there. So the periods are the same. So let me write that down. And let's see, how much is it? It's 4 pi. And the amplitude, I should put the amplitude is the same, so it's at 1. Now shifting. It looks like g of x is shifted to the, I could say to the right or the left, but I'll just say to the right. So there is a shift, the blue graph is shifted to the right pi units. So g of x shifts right pi units. Because every tick mark on this graph is pi. Okay, that's how I know, because there's 4 tick marks and the fourth one is labeled for pi. So the blue graph, if I shifted back to the left pi units, it would be right over the red one. Okay, and that's it. Alright, so 33, well, from this point on, we're going to be graphing the functions. Okay, so f of x is sine x, the amplitude is 1, the period is 2 pi. And then for g of x, the amplitude is 4, but there is a reflection over the x-axis, and the period is 2 pi. Okay? So I'm going to use this kind of orangey color for f of x and green color for g of x. I did not label the x-axis yet. Let me see. The period is 2 pi, so I'm going to count 4 tick marks. 1, 2, 3, 4, and that's going to be my 2 pi. Oops. So then that's pi and pi over 2. That makes this one 3 pi over 2. Now they're asking you to graph 2 periods. Okay, so in class we only graphed 1. So let me go ahead and label every 2 tick marks is a pi. So this would be 3 pi. And this would be negative pi. So what I'm going to do is I'm going to graph the full period like I did in class, and then just extend half a period to the right and half to the left. Okay, so this being a sine, we have the zeros at the beginning, middle, and end. So here, here, and here. The maximum is 1/4 of the way. Remember, the amplitude is 1, and the minimum is 3/4 of the way. So I'm going to write that over the 3 pi over 2. And so at 2 pi, from 2 pi to 3 pi, that's the left side of the period, right? So that would be that, it would go back up to here, and then here. On the left side, on the negative side, okay, the graph goes down, so it would have another 0 here, and then here would be a minimum. Okay, so here is the period, the full period right there. Okay, it's kind of messy, sorry. And then it just continues. It goes on the right, it goes up and back down, and on the left, it goes down and back up. So there's 2 periods right there. For g of x, the zeros are beginning, middle, and end. The maximum is 1/4 of the way, but then it has a reflection, right? So instead of being up on positive 4, it's going to go down to negative 4. And then the minimum is 3/4 of the way, which would be 3 pi over 2. But again, the reflection moves it from negative 4 to positive 4. So we have this curve right here. Here's 1 full period. And so I'm going to do the same thing. I'm going to do half on the right, half to the right, and half of a period to the left. So that means that again at 3 pi it's going to be another 0, and at 2.5 pi it's going to go down to negative 4. Okay, because of the reflection. On the left side, on the negative side, it has a 0 at negative pi, and then at negative pi over 2 it goes to positive 4, and then goes back down, and then the arrows. And that's it. Alright, so for 35, same thing, we're going to answer the amplitude period, and then, or any other transformation. So here, for f of x, the amplitude is 1, and the period is 2 pi over pi, which pi's cancel, so we have a 2. For g of x, it's